Okay, today we're going to do compositions of functions. And composition sounds just like the word to compose, right? If you compose a letter, you write a bunch of thoughts down. Or if you write a composition, it's a bunch of thoughts. If you compose music, it's a bunch of notes put together to make a song, or a bunch of instruments put together to make a song. So we're going to put a bunch of functions together and make a new function. First thing you have to learn is today's new symbol. It looks like a degree mark, and it means to follow. You're going to see it written as this. Say you have a function j, and you have a function q. And if I wanted to compose them, I would write it as such. J follows function q. So this is giving us direction, meaning that q has to go first because j is following q. Another way it can be written, and this is actually the more common way, is as such in double parentheses. Kids like it because this looks like PEMDAS. And we know in PEMDAS we have to do what's in parentheses first and then followed by J. Okay, so what is this going to look like? It's actually really simple to do. Let's make up two functions. Let's make up an easy function. Let's call function J the function where you double everything. And let's call function Q the function where you add 5 onto everybody. So your homework tonight is going to look like this. It's going to take one of the functions, it's going to follow one of the other functions, and then they're going to have you look at a specific point. Let's do 4. So this is saying put 4 into Q, get an answer, then take answer and put it into the other function. So in this case, I would take 4 and put it into Q. Okay, and what does Q tell me to do? Add 5 onto everybody. So 4 plus 5 is 9. So now I'm going to take that 9 and put it into J. And what does J tell me to do? Double everything. So I double 9, I get 18. So therefore, J, when it follows function Q at the number 4, will result in an answer of 18. Okay, here's a little PowerPoint that makes it a little easier to see. Okay, so we're going to start here. This says take 4, put it into function G, and then take that answer and put it into F. Okay, so let's watch the PowerPoint. There's 4 going into G. So G says to triple it, so I'm going to triple it, get 12, and now I'm going to put that 12 into function F, and 12 squared is 144, 144 minus 5 is 139. So there, when I compose those two functions together, when I put them together, I get that as an answer. Now I'm going to go backwards. Same functions, except now I'm going to go in a different order. This time I'm going to put 4 into F first. All right, and what's my output? 11. So now 11 is going to go into G, and I get an output this time of 33. So as you can see, composing functions is not commutative. When I did them backwards, I did not get the same answer. So that's composing functions at a specific point. How about if we wanted to compose functions onto each other? So if you see right here, I'm not putting a number in, I'm putting in x. All right, so I'm going to put x, and I got into Whoops. We're going to have to start that over again. That kind of jumped. Okay. Okay, let's take x and we put it into function f first. When I put an x into x, it doesn't change. I get the same function out. Now I'm going to put that in for x. So every time I see an x, I'm going to replace it with 2x plus 1. So there's my answer, 10x plus 5. Now that's a little confusing, so we're going to go inside the function brain, and we're going to look at that a little slower now. When I put x in there, this is what it looks like inside of the function. See, the function is waiting for me to put something in for x. What did I put in for x? X. So that's why 2x plus 1 came out. Now that's going into this function. So let's look inside this function's brain. It's saying 5, and it's waiting to multiply something by 5. And was it waiting to multiply by 5? What I put into the function, which is 2x plus 1. So that's why you got out. Come on, come out. There it is, 10x plus 5. All right, one more. Let's do another one. Let's put x into g. So by now you think you got it, and x squared is going to come out. And now I'm going to put x squared into this function. So this is telling me to cube whatever I put in and then minus 8. So when I cube x squared, I get x to the 6th, and I minus 8. All right. One last little thing. This one. Let's say I wanted to compose this function. No, let's not do that. Let's do this. Let's do g composed onto f of x. So g follows f of x. That means I'm going to do f first, and then I'm going to do g second. So you're thinking, what are we putting into f? How do I know where to even start? Well, guess what I'm putting into f? That's right, the x's. So I'm putting 1 in, 3 in, 5 in. And let's get rid of that point, because that'll make things bad. Let's just ignore that point. There, it's gone. When I put in a 1 into function f, I get back a 0. Get it? X is the domain, the input, and this is my output. So when I put, here's function f. When I put a 1 into function f, I get back a 0. Now I'm going to take that 0 and I'm going to put it into function g. Let's see what I go over here. When I put a 0 into function g, what comes out? An 8. Okay, let's do that again. When I put a 3 into function f, out comes a 4. And when I put a 4 into function g, out comes a 2. And the last one would be a 5. When I put a 5 into function f, out comes a 2. And then when I put a 2 into function g, out comes a 7. And you can see now why I had that extra point. It just wouldn't work. And some of you may be asking, like, well, what happens if I put a 7 into function f? Well, look up here. Do you see a 7? Yeah, nothing happens. The machine breaks down. Null set. Okay, that's it. See you tomorrow.